Yeah, I'm Doug Burman, along at SmartThings. I'm a Sagittarius. I don't know, been around mostly from the beginning of SmartThings and worked through the genesis, being fulfilling Kickstarter backers in 2012 and 13, all the way to like being bought by Samsung and taking our scrappy startup and being empowered by one of the biggest electronics manufacturers that exist in the world. Fast forward a little further, and here we are today. So as part of that Kickstarter program that we had before, I can give you a little history if you don't understand where we're coming from. 2012, we were backed by Kickstarter in one of the big record-setting amounts of funding, and 6 months later, in what is now seemingly an anomaly, we launched product, which includes our hub, the thing that connects your home to our cloud. We launched 3 products, a multi-sensor. We launched a motion sensor, and we launched a presence sensor. Along with that, we also created a developer ecosystem, including forums, simulators, an IDE, and even beyond that, an Arduino shield to help people create devices and attach them. So there's a lot of things got done in 6 months, and it was insane. So I commend some of the people that are in the room that have gone through that, and it's really awesome to see where we're at today. I feel like a little flattery in seeing SmartThings in front of everybody on stage, in front of a huge audience. It's just insane for me. So thanks to everybody for helping us get here. So what is SmartThings? In SmartThings, we talk about our company as being the easiest way to get your home to be a smart home. And we have the largest ecosystem, and you can see some of the metrics on the screen. If we want to break this down a little bit further and dig into the details, you can see the functional blocks that make up our platform as a whole. You have the client, which is your remote control, your automation setting up tool, like how you interact physically with the platform. You have the cloud, which is mostly everything, like all of the things we're talking about today and all of the developments that we're moving forward with, like going into the future. The cloud is getting bigger, more sophisticated, and it's taking on like a whole bigger new life. But you'll see the translations from device events have been translated in the cloud traditionally. You'll see some of the smart apps, like the actual executions and rules that have all existed in the cloud. And it is the linchpin of our platform as a whole. And then you have the hub. This is why we're here today, I guess, talking in this session. So the hub, connectivity has really been its focus. I think when we started, we started with a pretty simple basis for our hub. We had radios and connectivity layers to get some of these low power devices on the network. And moving forward, ZigBee, a lot of those have existed for a long time and are a building ecosystem. Z-Wave, you're taking hundreds and hundreds of devices and linking them up to the cloud. As that's evolved and we've made more hubs that are more capable, now we're taking a lot more intelligence and pushing it into the hub. I think if you recall some of the previous sessions, and you'll remember people saying stuff about pushing things to the edge and like getting a lot more features out closer to where the devices exist. So the proximity and the capabilities that exist on the hardware can really drive a smarter ecosystem than a lot of competitors have had in the past. So let's go over a few of those and where we're at right now. I'm not going to talk about some of the future plans yet, but we have relaunched our local execution story. In the past, this was something that was a little too cumbersome to try to get onto some of the other platforms that we want to play in this whole IoT space. So we re-architected and made a whole new framework from scratch And it's targeting scalability, platform portability, and moving towards that edge of the IoT space. Some of the core things that you'll notice here is we'll talk about protocol translation and how that's changed, and we'll talk about some of the rule-based execution. But as a whole, this whole local execution framework is the beginning of many features that will be rolled to the hub, and we'll touch on a few of them right now. Offline execution is a trait that allows a lot of local running devices to function as they would normally when they're connected to the internet. And you can think of this as enabling your normal status quo of what you would expect out of SmartThings, even when there's an outage, and there's other scenarios that you can come up with. I know people have talked about battery backup and offline as some of the holy grail for security applications. But imagine if you came home and you cannot open your garage door because your internet was out, or your cat didn't get fed if, if there was an outage on the internet because it was driven by the cloud side. So moving a lot of these rules locally expands a lot of the peace of mind and like how much you can depend on the platform, because the only way it's not going to work is if it's completely unplugged. The second side of that is all of these events will still get transmitted to the cloud. While you're offline, you may have a security event where a siren went off and somebody broke into your house, and you want to know what that looks like, and painting that picture still happens as soon as you connect back to the internet. Faster execution, I feel like this is the one that I'm a really big fan of. I think as you've experienced IoT products, a lot of them feel a little bit sluggish, and we're very much trying to address this in a fashion where if you think of how a light switch works now, a traditional light switch feels instantaneous. We're trying to take that approach and move it towards all devices that can run locally, as including a motion sensor, turning on a light. That button perception lag is something that we're very much so pursuing. So we can take and look at what the local execution framework looks like in a really rudimentary block diagram. So if we start down at a sensor, this could be a Z-Wave, a ZigBee, Bluetooth in the future, LAN sensors, something that functions as a door contact. And that gets sent up in its raw form to the protocol handler. The protocol handler has the job of taking that raw message, if it's in ZigBee speak or in Z-Wave speak, and translating that into something that is a common capability language. And in our world, capabilities exist both in the hub now and in the cloud. So if you have a switch dot on, if you're a developer looking at controls or a motion event, it looks the same here in the hub as it does in the cloud. And then you see the second side of that is this execution evaluation block. Rules from our cloud can be pushed now down to the hub if they're qualifying, as in if the devices are running locally that meet the criteria for the rule, it can automatically run this in the hub. So it's taking the idea of moving everything closer to where it actually happens. And if it's eligible to do this, we will execute this in the hub. And you'll see the benefits of offline execution and some of the speed that I'm talking about. So in this use case, you would have a general flow of the door opens, it goes into the protocol handler, and if it was ZigBee, that translates to capabilities. That goes to the executor, which has a rule, and if it matches that rule, it will trigger the entryway and kitchen lights to turn on. The resulting transaction is then also sent up to the cloud so that every other smart app that exists in the ecosystem can and will function based on this. So if it is on the other side of this, a protocol handler that would be in the cloud or a device type that's in the cloud, if it's not marked to run locally, it would pass up as it normally does in our traditional ecosystem and generate events. The translation would happen in the cloud. the app or rule would execute in the cloud, and it would be a seamless interaction. So it's something that the developer doesn't have to necessarily worry about, but you may make design trade-offs to take advantage of it. So we're talking about the Hub SDK today, and in the history of SmartThings, you've had a few ways to integrate. If you're a device manufacturer, you've been always able to certify your device in our Works with SmartThings program, and now we're opening the door up for a more formalized SDK framework for people that want to take advantage of the Hub technology being in their device itself. So why would you want to do that? It's a large question, right? If you're in Scott's presentation earlier, you heard of the idea of making every home a smart home, and that ambition is reflected in this program. I think as you see a lot of households right now that have dedicated hubs, a lot of the goal would be to take that and make that basically vanish. There's already a lot of connected devices that exist in your home, and you want to take that same core technology that's regularly updated and maintained and is linked to the cloud and has a vibrant, active community behind it, and you want to make that a decision that the customer doesn't necessarily have to make. If you're a router or speaker manufacturer, adding our capabilities to your product enhances the user experience for all of your customers, as well as extending and getting rid of a potentially ugly white box that exists in the corner that you don't need to have. So some of the additional reasons, I mean, we can go into these a little deeper in the question session, but I mean, there's branding, revenue, product relevance in your market. But in just more simple terms, adding the SmartThings Hub into your product gives your customers significantly more value as it becomes the center of the smart home. If you had a speaker and your core function is to play sound, now you add a whole new value proposition to your product where everything is connecting through it. It's actually a vibrant part of your connected home space. Additional reasons, this industry is growing a lot. In the coming years, you're going to see a lot more of this connected thinking vision and see it come to fruition. Some things you want to pull from this slide are the unification of the user's interface, and we've talked about that in the One App projects. Devices and solutions coming to a trusted brand. I think everybody would agree that Samsung is a large player in this space, and people have a level of trust in them, which is what drove them to number 6. The smart home is going to skyrocket, and tons more devices are going to be added to the ecosystem. So to simplify this program down into some more basic steps, I think you would look at this as a pretty short list. I mean, there's obviously a little bit more to this than what is in a few bold items, but we're trying to make a developer program that reduces the barrier for a developer to be able to take this and get this into their product, to get a proof of concept in place and run in your internal playgrounds. So you obviously need to get the SDK, obviously, number 1, download it, get access. You develop your product-specific code, and this has a few different corners on it. For the most part, if you're using stock designs for the connectivity pieces, most of it is already done for you. The corner cases come where you're going to have to isolate and set up your actual device to support the security constraints and link together the running ecosystem. You have to decide on a radio option, and we'll talk about what those are right after this. And then obviously you would certify with now works as a SmartThings Hub program. In the same dumbed-down version, you can see right now we have Hub Core taking in most of the work, and this is part of the SDK and really trying to simplify what it looks like for a developer. So you would hook up the radio interfaces to both ZigBee and Z-Wave right now, and you would have to draw lines on security for storage and other security-related materials, but most of the guts of what a hub is actually all within a circle, and you don't have to touch that part. So what does it take to be eligible? POSIX operating system. Right now we're running on mostly Linux-based ecosystem, so I would say Linux and BSD are probably the most common in that category that we would be targeting and looking for. And then Hub Core is part of a bigger ecosystem. The Hub SDK is one component, if you rewind back to the previous slide, in our whole platform where it has to stay lock and step with our cloud. It needs to be up to date with the mobile interfaces. So we have an expectation of updates being rolled out. On top of that, security is always a reason that you would roll out updates. If there's a new Heartbleed bug that comes out, like this needs to be a normal part of the development ecosystem. And as IoT grows and expectations change, product life cycles may be something that we need to take a transitional shift in how we think about how long do you support a device. Like, what is its maintenance period? What happens when it goes out of the maintenance period? And RAM and storage, I mean, we obviously need a place to put our executable and SDK. We need a place to put updates for devices that connect to Hub Core and connect through it. So at this point, we have been talking about rough numbers around 64 megabytes for both, and we'll talk about finalizing those numbers in the coming future. So one of the radio options that we're going to talk about now is the fully embedded. So this looks pretty similar to what our hub is right now. It's fully encompassing. The product actually has the radios embedded in it. We support all of the same things we would support in our product. And I think this is arguably like the best way to integrate a hub into a product. If you buy a speaker, like you would want all of everything contained instead of add-ons. All that said, we make a dongle. Our V1 of the dongle I have right here, and this is what enables the NVIDIA project, which you can see outside, and we'll talk about that a little bit more at the end of this presentation. But SmartThings provides the firmware that goes onto this dongle itself and the update path for this device and the Linux drivers to be able to communicate with it. It's a fairly simple device, mostly connected radios with UARTs and some GPIOs to control reset. And the second radio option is where this comes into play. The Link enables the NVIDIA Shield to be a fully functional hub. So how to get started in this program? Reach out to business development. I mean, we have some people here. You can heckle them right now. And we'll be offering the SDK to select partners. So contact them and we can move forward. So back to the Works as a Hub program. This is the now deprecated, I guess, logo since we've updated a little bit. So here's a few success stories of where we've already integrated our hub technology into products that exist. We have the ADT panel, which is a fully embedded radio option. The radios are actually in the panel itself. There's no add-on to connect it. And this solution is a trusted brand for security, and we've taken seriously the security paradigm and moved it like a step forward from what is traditionally and still available for security. So with Hub Core built in, beyond being able to find your home health and understand your fire safety, if there's a leak, all of those things, you still have all of the core functionality that's available in SmartThings. It's not degraded by any means. It's a fully functional SmartThings Hub with a whole addition of peace of mind and monitoring that comes along with it. The Shield, this is an example of a partially embedded solution. I don't know if anybody else has had or played with the Shield, but it's actually pretty cool. I love this device. It does all the streaming. You can connect a ton of things through it. You can game through it. And you can also now have this as the center of your smart home with the dongle attached. And third, the Connect router. So the Connect router is a modular internet router solution. I think we've seen an uptick of these in the ecosystem, and Samsung's take on it extends that into a situation where you're giving the user both internet and expandability. So if you have a strange layout or a garage that's further away and you want to have consistent internet across your space, you get that, but you also have the smart home capabilities built into it. And since I have a little time here, I think I'm going to do a quick demo just to see how I can tempt the demo gods and show you how you can get set up with the Hub running on just a vanilla flavor of Ubuntu. Okay, so this is our repository checked out right now. And as we're talking about this is the V.1 of what we're trying to do as a product. We're trying to evolve this from where we're at now into something that's more formal, fully documented, and cleaner lines and separation. So this demo is an early view into where we're at and how things would work. To get started, there's an environment setup script. And what this does is customizes the environment for what you're trying to build for. Typically, in embedded programs, you will not build on the hardware that you're going to put it onto, but you'll build on a machine and cross-compile it. In this case, I'm just building for the same machine that I'm running on right now, so I won't have to do anything custom. But this environment setup for each fully different platform that you would launch, you would have an option that would specify what the target is, and the config would go into the environment setup. So that could be a thing, and that's how we build actually for our Shield. But for the sake of argument right now, we will build for this VM. And if anybody's familiar with normal Linux processes, it's as easy as making. And this will take a while, so we'll skip that. So as a result, if you fast forward in time there, it was really quick. I don't know if you all saw it, but there is a binary that was a resultant from that. And so the second step would be, after it's compiled and running, we need to find out a few things about your target and what exists. So in this case, I'll take this dongle and plug it into my laptop. And to find out how to connect that to the hub process, I'll look here in standard dmessage utility in Linux, where you can see what's connected, and that gives you the device identifier. Additionally, you need to specify what the internet interface is. And again, another standard tool to find this out. So with this info, I need to config one file to tell it where they point. And you can see I took the info from dmessage for the serial ports for ZigBee and Z-Wave, or those two tokens, and the Ethernet interface. And with this, I can start and run hub core. So you notice I had to actually enter my, well, not successfully, enter my password to kick this off. And this is where some of the customization exists. Right now, I'm running this as root, which is not what you would want to do in the end. And setting up the Ethernet and all of the drivers for the serial ports to the radios are all things that need to happen in that previous step, number 2 on our list, where it's customized for your target. I'm just going to bypass that for now for the demo's sake. And then to know that it ran, I'll run another script that I just put together that's going to check to see that it loaded all the credentials correctly out of the logs, and the same for the connection to the cloud. So that's all I have today. Is there questions? Yeah, I can repeat it. They're manufactured for specific areas, and how we've handled this is making a version that exists and is targeted for each one of those 900 megahertz bands. Is what you're referring to, as in Australia has a different 900 megahertz band that's not exactly the same frequency as what it is in the US or Europe or some spots in Japan. And we would be targeting a link device for each one of those zones.
Hi. As SmartThings has opened up this program for Works as a SmartThings Hub, is SmartThings still planning on continuing with the traditional hub model?
Yes, this is supplemental to our traditional hub model. I think you'll see some traction and things happening in the next few months. I don't want to talk about them right now, but we will continue to make hubs. I think as an add-on to that, the goal of what we release into the program, if we release a version 10 into our own hub firmware, we want that same core functionality 10 to exist in each one of these embedded hub projects.
So just to add on to that last question, has there been any discussion around embedding a hub with the Samsung One Connect box for our smart TVs?
Has there been discussion about us integrating the hub into a specific product? Sorry.
The Samsung One Connect box, the smart box for the smart TVs.
Right. Yeah, that's not my area to talk about specifically. I think that's something where you can follow up with business development, and they'll connect you to the right people.
Sorry, I feel a little silly because I came in late in the presentation, so maybe you covered some of these things. Feel free to just tell me off. One question, two questions. One, in the hub architecture, is there going to be any direct connect for user interfaces? So I'm with Action Tiles, right, and we have to go through the cloud, and people want to be cloud independent?
Yeah, so some of the talk about what we were covering earlier was the whole new local execution engine, and the features we're announcing today are the faster execution feature or trait of that engine, as well as the offline use case. I think, as I was saying in the slides earlier, this is like the groundwork, and we're considering many things to look at for like how we can leverage having more info about the devices locally, and like how we can expose that to customers and developers.
That's good. And the second question is on device connectivity. Right now you have ZigBee Z-Wave and LAN Connect as well as cloud to cloud. But from a hub standpoint, it's those three. We know we've been waiting for Bluetooth, and then other types of connectivity can now be done externally, because if this is going to run on any hardware, somebody might have low pan and other kinds of chips in them, right? Thread and so on. Is that a part of the architecture?
Right now we're talking about ZigBee and Z-Wave. I think as you see the hubs evolve as a whole, there'll be more radio interfaces. Specifically, I don't have an answer for you right now, but we are looking at expanding into some of those connectivity standards that we have not played in before. And if you look globally, some areas have different technologies that may be like more niche to where they're at. As an example, some of the DECT ULE stuff is pervasive in Germany, but really doesn't exist here. So I think we'll have to balance like what has the most impact and the most devices connected to it, and make decisions based on that. So if there's input on radio interfaces that people find a lot of value in that we're not touching, we would love to hear that. Yeah,
because the reason I'm bringing it up, right, there seems to be this separation between hardware and radios and the architecture of the hub, right? And now, so that was an opportunity for those to be more modularized and hopefully more flexible.
Yep.
Agreed.
Missed your talk, but just wanted to know a little bit about ZigBee or Z-Wave, like how the security is handled, and if I bought a new device, how do I provisioning my device?
You're saying the new ZigBee and Z-Wave features?
Yeah, if I bought a device, what's the process of provisioning the device or pairing the device?
As a whole in SmartThings ecosystem?
Yeah.
So when we launched, we had this concept that I feel like a lot of people have been copying, that is a pull-to-pair, where in ZigBee, there's an exchange that happens back and forth. But to really simplify that user experience, as soon as you pulled a tab out of the batteries, the device will try to actually pair to anybody who's listening. And that is universal for ZigBee, as it's powered on or a button press happens, it will look for the device. But the pull-to-pair is something that we kind of pushed really hard on to make it so there was a lower barrier to entry. Z-Wave is a little bit different, as in almost every Z-Wave device doesn't come just automatically scanning. There's some exceptions. But the join flow in Z-Wave is different right now. And if you look to the short future, both of those protocols have some additional security that's getting added into them. There's Z-Wave S2 that adds keys and an install code, and similarly in ZigBee 3. So you'll see the user experience change a little from what it is right now. The pull-to-pair may not exist if you wanted to have a more secure connection, but we will continue to evolve with those standards and move as makes sense for the customers. You can't ask a question.
Of course I can. Do I have to use a SmartThings dongle, or can I make my own dongle and load whatever firmware on there?
Yeah, we're not specifically attached to having to use our specific dongle. I think this reaches back to what Terry was asking and having more radio interfaces. I think the difference in some of the things that we have right now is some of the code that exists on those devices is more custom. If you have a normal ZigBee stack, it doesn't support that many connected things, and we have some things that we've added into the firmware that goes on the dongle that expands that and makes it more robust. I think we're willing to share that along with the program with other people, but we're not really tied to us selling you a dongle.
Great, thanks.
Come on, I know you guys got some more questions. Awesome, we'll give them another round of applause, guys.